I am so glad to see so many people here. My name is Ren Smith, and I'm Interpretive Programs Manager for Bernheim Arboretum and Research Forest, south of Louisville, Kentucky. I think most of you probably know that. But I am so excited to have Olivia Carril with us this evening. She's kind of our opening act on our week of Bugapalooza, a celebration and an investigation in all these small creatures. So one of the things I'd like to say about Olivia, I know she's going to talk a little bit. I'm going to nudge her into talking a little bit more about herself as we get going. But I was introduced to her work through Justina Block and Tammy Clemens, and maybe Seal Beckner was also aware of your work. So Tammy Clemens and Seal Beckner are a couple of our volunteer naturalists who are also very into the native bees, particularly the mason orchard bees. So they introduced me to your work and this amazing book that you have published called The Bees in Your Backyard. I know you were co-author in this, and you have another book or two in the hopper. And I definitely want you to talk about the second one because I know it's on Eastern bees, and a lot of us are in the East, so we would love to hear that. But you got your BS from Utah State and your master's, you were doing work on the relationship between bee species and their particular habitat needs. And then you got your PhD from Southern University at Carbondale. But you spend a lot of time in the field. I know this because we kind of did a little bit of this as we were trying to connect. But I knew you were out there in the field doing what you love. So it's my great pleasure to introduce you to Olivia Carril, and I'm going to let you turn it over to you, Olivia.
Thanks, Ren. Let me see if there's an echo. Does that sound okay to everybody? Sounds good? Okay.
Good.
All right. I have to thank you, Ren, for giving me the opportunity to meet all of these folks who are
We're getting a little bit of echo.
To be here this evening to learn a little bit more about. What if you mute yourself, Ren? Let's see what happens there. How about now? Did the echo go away? Yeah. Yes, I'm seeing some nodding heads. All right, and I'll double check my speaker and microphone. It looks good on this end. The Bernheim Forest is a place I have always wanted to go. Justina's been telling me about it, raving about it for a couple of years now. And one of these days I'm going to make it out and see that place in person. I'm sure it's a treasure, and it would be fun to see what bees are happening down there. It sounds like you guys have looked a little bit at that. I'm going to do an overview tonight of bees in general across North America. And we'll talk a little bit about some of the specific bees that you might find in Kentucky and in the Eastern US. And I'm going to start by sharing my screen with you here. I threw together some pictures of bees so we could kind of talk about them a little bit. Bees is something I love a lot, but I'd like to explain to you why I'm the person that's talking about them with you here tonight. This is something that I've been studying for almost 25 years now. I can't believe it. I've been studying bees in different areas around the United States, and I've had the opportunity to collect bees in other parts of the world. Right now, I live in Santa Fe, New Mexico, and so I spend most of my time doing bee surveys for national parks and national monuments, mostly in the West and mostly in New Mexico. I'm also studying some rare plants here that we don't know what is pollinating them, trying to see if maybe it's special bees and learning about that. And then in the future, I hope to be doing monitoring in more areas around the West. So I stay pretty busy. I spend a lot of time in the field, and to Ben's frustration, I'm sure, usually it's areas with very little cell phone service. So it's been hard for us to connect. In addition to doing all of this bee work, I'm also a mom. I have 2 little girls, and I drag them everywhere with me, whether they want it or not. They have to come along. They're getting good enough with a net now that I actually have started paying them for the bees that they collect for me. And my thought when I started this was that if I gave them like $5 a bee, maybe I'd be out $10 by the end of the day. And the first day I was out $75, those little stinkers. So I've had to lower my rates and adjust, but they're getting pretty good. I'm training up some great field assistants. In addition to that, I'm a middle school science teacher. So when I'm not out in the field in the summers during my winter season, I spend a lot of time in the classroom. And that leads me, these two things kind of come together in the thing that I most love to do, which is teaching about bees. It combines the best of both worlds to be able to talk to folks about the two things that I love so much. And so that's what we're going to do tonight. I'm going to try and teach you a little bit about bees as we go here. And I guess Ren asked that I point this out. In addition, I also write books sometimes that it's another way of teaching about bees. A few years back, my co-author Joe and I wrote the book, The Bees in Your Backyard. That came out when my daughter was like 6 months old. So it was that 5.5 years ago. And then coming out next week, fingers crossed that it actually happens, we wrote The Common Bees of Eastern North America. So it's a done deal. It's gone to the printer and everything. And anyway, that'll be coming out. And I'd love to hear feedback on whether it's actually useful for folks. But the idea with this one was to create a book that was a sort of a species level guide, almost like a bird book, but for bees. Obviously, with as many species as there are in the Eastern US, we couldn't include all of them. So it's a subset of the more common ones, the ones that are easier to identify, the ones people are most likely to be seeing around. Other than that, I would say the most important thing to note on here is email address down at the bottom, thebeesinyourbackyard@gmail.com. If at some point in the future you think of a bee question or you take a picture of a bee somewhere and you didn't get a chance to ask your question tonight, feel free to reach out to me at any time in the future. I'm happy to answer any questions. And if you want to learn a little bit about bees, we post on our various social media platforms fairly regularly with just tidbits and interesting information about the bees that we're seeing and the things that we're learning, Joe and I. So anyway, reach out to us at any point in the future if that interests you. When Joe and I first started writing this book, I had just wrapped up my PhD, and Joe was a brand new professor at Utah State University at the Tooele Extension. And we both had this idea together that we should help people learn about bees the same way people learn about butterflies and beetles and birds and all of these other wonderful creatures. And to get a sense for how much people already knew, we published an online survey and we asked about 1,500 people to participate. That's how many decided to. We would have taken more had they. And we asked 3 questions in our survey. And the first question we asked was, how many bee species are there in the United States? And so I'm going to ask you guys this question. You didn't know you're going to be quizzed tonight, but you are. How many bee species are there in the US? And I'm going to make it simple and give you multiple choice answers here. So 1 would be 50, 2 would be 100, number 3 is 850, 4 is 4,000, and 5 is 20,000. So go ahead and hold up your fingers for 1 through 5. Let's see how we do here. I'm seeing some 4s, 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 3, I see a 3, a 3, a 3, no 1s. So that's good. Nice, you guys. Man, if I were your teacher, I'd be giving you an A right now. Yeah, the answer is 4,000. That's really good. Most of the people that participated in our survey said there were less than 500, and we made it even more open-ended. It wasn't multiple choice, it was fill in the blank. And most people said fewer than 20 species in the entire United States. Of course, the actual number we think is somewhere between 3,500 and 4,000. So most people don't know how many bees live all around them. These bees are everywhere to be seen. And the next question we asked was whether people could identify a bee. And so we gave them these exact images that you see here. And there's 10 images total. So go ahead and take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I won't embarrass you. I won't make you call out and tell me. I do that in class sometimes where you like pick the person that looks like they're falling asleep and ask them a question. I won't do it. Just take a look, see if you can figure out how many of those are bees and which ones. And now I'm going to show you the answers. These are the bees. So number 2, 4, 6, 7, 8, and 10. Give you a second to look at that. And now I'll show you how our participants did, so you can kind of compare yourself and decide if you're at the top of the class. So most people did really good with the bumblebee, the honeybee, and our little sweat bees. Almost 100% of people knew that those creatures are bees. And what's funny to me is those are the 3 that are most likely to sting us. So what I think is that people know a bee because they know what a sting is. And if it doesn't sting you, they really don't consider it to be a bee. Down at the other end, most people know that flies and butterflies and grasshoppers aren't bees. But there's this area in the middle that confused people, somewhere between 40 and 60%. So let's average and say 50% of people knew that those were bees and 50% didn't know they were bees. So the ones that you see here, and I don't know if you can see my cursor. Someone give me a thumbs up if my cursor's moving. Okay, good. So the one that I'm doing there, that's a mining bee. They're super common all across North America. You can definitely see them in the regions of Kentucky where you guys maybe are, most of you. Over here on the other side, this is a green metallic sweat bee. There's 4 different kinds where you are that you should see. And down here, this is a mason bee. They're really common in the spring where you are, and they're the ones most likely to live in your bee hotels if you put up a bee house for them. In the middle here is something that in the east, it's called a cow killer. In the west, it's sometimes called a velvet ant. And that one's not a bee, but a lot of people thought that it was. So then last question, you're almost through with your quiz here. The last question we asked was on a scale of 1 to 5, with 5 being super duper important. How important are bees? And all of our 1,500 participants, I love it. I see the 5s up there. All of our participants, but like 2 people said 5. I don't know what was up with those people. Maybe they'd been stung recently or something. But generally speaking, we have this situation now where people know that bees are really important, and yet they don't know what a bee looks like, and they don't know where to find one or how many kinds there are around them. So there's this big disconnect between our understanding of something that's valuable and what that thing we value is. And so Joe and I kind of want to fix that. And one of the main reasons is so that we stop seeing these things, which kind of make us like twitchy. When we see campaigns to save the bees, lovely posters with pictures like this. I wonder if anyone knows off the bat what's wrong with that. That's not a bee at all. That is not a bee. This is a yellow jacket. It's a close relative of the bees, but it's not a pollinator in the same even level of magnitude that most of our bees are. Here's another. This is on Zazzle. I don't know if any of you have ever looked at Zazzle. You can make your own t-shirts there. And someone made this nice Save the Bees t-shirt you can buy for $25.50. And that, you guys out there especially should know what this is right now, because they were, I think, in abundance in your area this year. That's a cicada. So yeah. And then here's another. This I came across totally naturally. I was looking for a puzzle for my little girls, and I typed in bee, and here came this cute puzzle from Melissa and Doug. But of course, that is what we call a syrphid. It's a flower fly, but it's not a bee. And finally, you guys are going to laugh. This was at a Entomological Society of America meeting. So this is where all the experts in the world, or in North America, on insects come together, and in the middle of the room there's usually these tables with books on different creatures, and you can go buy books on dragonflies or whatever your interest is. And they had a whole table of bee stuff, and Joe, my co-author, was looking for something as a souvenir to bring back to his kids, and he opened up one of the kid books, and it says Meet the Bees, and again the image there is a fly. So we feel like we've got our work cut out for us. One group at a time, we're going to help people understand the difference between bees and flies and wasps, and why each of them is important in their own way. So let's start by talking about what a bee is. Everyone should recognize this little gal down here in the corner as the honeybee. And this is, I'm going to pause for a second. This is a good opportunity to see if I can familiarize you all with a feature on Zoom here called the chat. Down there, it looks like a little sort of comic box. And you can type into that box if you care to, no requirement. Type in another kind of bee that you might know of. So some we've already talked about tonight. So if there's another kind of bee beyond a honeybee that you know of, go ahead and type into the chat there what kind of bees you guys can think of. I see carpenter and mason and leafcutter in here. That's great. Another carpenter, good. Those are really common where you are. They really make themselves known. Mason bumblebees, excellent. Very good. Any others come to mind here? Let's see. I'm going to wait one more second. Good. Bumblebees. Great. Yeah, those are the ones that we think of a lot for sure. Bumblebees are a big deal. And the horn-faced, which is a kind of mason bee. That's very good. Yeah, those are all different kinds of bees. So in addition, of course, to the honeybee, we have our carpenter bees, our bumblebees, our mason bees. Sweat bees is one I mentioned a little bit earlier. We could have said sweat bees. And up here in the upper right corner, this one is a squash bee. Squash bees are also common where you are and an important one. So these are all just a subset of the different kinds of bees that exist in North America. To me, they all look pretty different from each other. So what is it that unites this very strange looking group of organisms all together in the group that we call bees? Well, if you look at the family tree for all insects, so this is just like if you go on Ancestry and make a family tree, same thing except for insects. And so the distance between any two branches indicates how closely related two things are. So the longer you have to walk, the less closely related they are to each other. And you can see down here at the bottom, there's a group that says Hymenoptera. This is the group that includes the bees, wasps, ants, and a couple small groups of things like sawflies and stuff like that. And if we zoom in on that branch and look at the finer branches, the little tiny twigs, it looks like this. So here is all of the different things in the Hymenoptera, including the sawflies up here at the top, some of our strange parasitic wasps, a lot of our rather normal looking wasps that we talk about. Ants are in here. And then down here at the bottom, all together branching off of where this star says number 5 are the bees. So all of the bees, what this means is that all of the bees come from one branch. We could take our pruners and trim one particular branch off and collect on that all of the bees. They are all related to each other, and they all arose from one common ancestor that was a wasp. And in biological terms, what this means is that bees are a kind of wasp. They're not even separate. They are not a separate group. They are a wasp, and they are the wasps that evolved to collect pollen off of flowers instead of grabbing some sort of prey to take back to their nest to feed to their babies. So the wasps are the predators. The bees are the ones that have switched to a sort of a vegetarian diet of eating flowers. So that's what puts them all together into one group right there. We know that of this group of insects, there's about 20 to 30,000 species worldwide. The number changes depending on who's gone exploring in Kazakhstan and discovered a whole bunch of new species for us. During my work on my master's in southern Utah, an area of sort of south central Utah, it was an area that's about 100 miles by 50 miles in size. And in that little area, I found 660 bee species. And of those, 40 were brand new to science. They didn't have names. Many of them still don't. And so if an area inside the United States can have that many new species, we have a lot of work to do around the world to really get a handle on how diverse the world is. In the US, we think there's somewhere between 3,500 and 4,000, and nobody's counted yet the bees in Kentucky. We have a good guess that it's somewhere between 300 and 500 species, but there is no list of bees yet for the state of Kentucky, which is kind of cool. It means some young scientist somewhere is gonna have a good time figuring that one out. East of the Mississippi River, there's about 770 bee species. So just to give you a sense, we could compare that to birds. In all of North America, I think there's 1,100 bird species. So east of the Mississippi, about 2/3 as many there. And if we break this down by state, and you'll notice, I don't know how many, we don't have a good number here. We think it's somewhere between 350 and 500 because there's 500 in Ohio in this area. But you'll notice a general trend here. As you move from east to west across the country, bee species richness tends to increase. And as you move from north to south, it increases. So that the areas of highest richness, the most kinds of bees, are found in the desert Southwest. New Mexico, Arizona, and California takes the cake here with 1,600 species. But when you think about that, they have the highest and lowest points in the lower 48. They have all these really interesting habitats you don't find anywhere else. And they have this huge latitudinal gradient. It's such a long state. It's not surprising they have so many for those reasons. So right here in New Mexico, somewhere over this T, I am in kind of the best place for someone who wants to study bees. There's a lot of exciting discoveries to be found down here. So let's talk, I'm taking you back to my childhood. I'm kind of dating myself here. I don't know how many of you remember Sesame Street, and they used to play the one of these things is not like the others game. I was always really good at it. So just kidding. We're going to play this with bees now. So one of these bees is not like the others, really not like the others. I'm going to let you think about it in your head for a second. And then I'm going to tell you which of these is least like all of the others. It's actually this lady right up here. The honeybee is a really amazing bee, but it's a poor representative for all of the bee species that we find in North America, in the United States, which includes all of these. All of these are bees that are found here in the US. That honeybee, as much as we know about it, is kind of the outlier. It stands out. And so I want to introduce you to a more normal bee life cycle. Let's go through the natural history of one of our solitary bees. And let me just say, now that you know how to use the chat, if I talk about anything that seems interesting and you have a question you'd like answered, feel free to type it in as I'm going, and we can answer questions at the end. Something I missed if I forget to say something that you're curious about. The first thing I want to point out is that while many people think about bees as coming in honeybee size, that's how big a bee is, they actually come in a wide range of sizes, ranging from bigger than a quarter, like the carpenter bees do, to much smaller than a quarter. These are to scale. This is the actual size of bees compared to the quarter that carpenter bee there is sitting on. This is what carpenter bees look like where I live. This little guy is called a perdita down here. There's about 600 species just within that group here in North America. And that's not even the smallest. So take a look here. This is the smallest bee in North America, again, compared to a quarter for scale, just so you can see. This one's called Perdita minima, and it only occurs in the Chihuahuan Desert, where it's a specialist on a tiny, tiny flower called a leafy spurge. So that's kind of cool. Unlike the honeybee, which lives in this hive, this above ground sort of hive-like structure in a colony, most bees nest in the ground. So they dig a hole, very much like a wasp does, many wasps do, or like an ant does. It's a hole in the ground. And inside that, they have all of the things that need to happen in a bee's life happen down there. So most bees, about 70% in North America, nest in the ground. Let's see if I can get this to play. Here's a video of a very cute little bee. This bee is, it's called a mallow bee, and she's digging her nest using her mandibles there to chew at the ground and kind of press at it with her arms to get it as smooth as possible. And inside that nest, if we were to look in there, let's see if I can go forward a slide here. Inside that nest, we would find, and I'm looking on the right slide here, there's one on the right side. You can see this long sort of tunnel that's kind of white coming down this main shaft. And then off of that is a series of small little chambers. And each of those little chambers gets a ball of pollen that the mama collects. There's no queen, there's no workers. There's just the one mom that built that nest and then flies out and gathers pollen and nectar that she brings back to that nest and puts into each of the little nurseries that she builds. So each of these little tiny chambers is a separate nursery for one baby. So she'll put the pollen ball in there, and then she'll lay an egg on top of that, and she'll backfill this. In most bees, they backfill this and seal that egg off from the entire world, from all of its brothers and sisters. It's by itself in this little hole. The egg hatches within 2 to 3 days of being laid, and that little larva, that little tiny sort of caterpillar thing that's in there, eats all of that pollen and uses it to turn into an adult bee that grows up in the dark alone, never having met its parents. Kind of interesting. Some of these get really deep. This is one that was dug up in south central Utah. It's a bee called Andrena hainesi, and it's about 1/3 of an inch in size. And the bottom of the nest was found 9 feet underground. I read last week about a bee that even tops that I hadn't heard about before. It's one that lives here in the desert Southwest called Exomelopsis solani. And this little bee is even smaller, and its nests are 15 feet deep. And what's really cool about them is there's one little hole in the ground that's the nest entrance. And you can think of it as like an apartment building in New York where there's one way in, but inside there's like, I don't know, 300 apartments all in there with different families. That one hole is the entrance for 900 bees that live separate lives in separate little places inside there, down to 15 feet under the ground. So cool. The bees that don't nest in the ground nest in wood. So you see this a lot in Kentucky. You guys actually have a higher proportion of wood nesting bees in Ohio, Tennessee, Kentucky, that sort of deciduous forest area where you are, than other places in the country. And these bees, if you look inside, they often line the inside with something sort of like wallpaper to kind of protect the little babies that are in there. And if you look inside, you can see the wallpaper here is chewed up material. And she has a series of little nest chambers with a ball of pollen. She has this mass of pollen, and then she's laid an egg right in front and then built a wall, and then a mass of pollen, an egg, another wall, pollen, egg, wall. Each of those bees, again, those little babies, is growing up by itself. So she drops off the pollen that's on the underside of her belly here. She scrapes it off in there. It's a little Michael Phelps flip. Scrapes it off. Caleb, maybe it's Caleb Dressel now. I guess we've moved on from Michael Phelps. And then she'll put an egg in there and seal that one off. What's interesting about these is when you think about it, this bee at the back here was actually the first egg laid, right? Which means it started developing before all of its brothers and sisters that are laid more towards the front, which means it's going to be ready to go earlier too and may want out of the nest, but it can't get out without chewing through all of its brothers and sisters. So how do we prevent all of those bees from dying as that one bee that's getting impatient back there leaves the nest? Well, one strategy that bees have is that female bees, when they lay an egg, have the ability to choose the sex of their offspring. So they can decide whether the egg that they lay is going to develop into a male bee or a female bee. An unfertilized egg, an egg that has no sperm attached to it, associated with it, develops into a male, and a fertilized egg, which has sperm released at the same time as the egg, develops into a female bee. So she lays the female bees at the back of the nest because they have more genetic material and take longer to develop, and the males at the front of the nest so that those females have the extra time and everyone hopefully comes out of the nest around the same time. What this means, so the way that she figures out whether to lay a male or female is, we think, by sort of counting steps as she walks to the back. And so for that reason, if you decide to build a little bee house somewhere, you need to think about how long the tubes are that you're putting in there for your bees, because if you make them too short, she'll only lay male eggs in there. So it's important to make those tubes long enough that she lays both sexes of bees. All right, let's move on here. Inside the nest, you may find little bits of petals. You may find pieces of leaves. You may find that she's painted the inside with a secretion that hardens into something like a Ziploc bag. And just for fun, I had to put that some bees actually nest in snail shells, which I think is really cool. Male bees do not participate in building the nest and gathering the pollen or any of that stuff. Most of them establish territories near flowers and wait for females to come and then try and mate with her before anybody else does. And at night in my yard, I often find them curling up in the flowers that were in their territory during the day and sleeping inside a flower, kind of wrapped up tight in there, which is fun. Out where you are, squash bees are one of the best because those squash flowers kind of wilt at night, and then you can squeeze the base of them and the little male bees that are in there will buzz back at you, tell you to leave them alone. Over here, this is a bee called Melisodes bimaculata, the two-spotted longhorned bee, and it's really common in your area. And here's a bunch of males. They actually form sort of a bachelor pad at night where they all kind of glom together. Even though they fight all day, at night they'll kind of hang out together and wait till morning when they go back to fighting. See. Okay, so let me walk you through the life cycle of one of these. And this could be any bee. This is a very generic life cycle, and obviously it would change depending on the bee. And just like the things we get in the produce section at the grocery store have a season to them, right? Like apples are cheaper at a certain time of year, and watermelons and cherries and rhubarb and asparagus, all of those things. There's a seasonality to the bees that pollinate them as well. So the bees that are out in the spring are very different from the bees that you see in the summer and in the fall, etc. And so I picked a spring bee, but this could have just as easily been kind of rotated around to be a summer or a fall bee. So when the bees emerge, say in early spring, the males usually come out first, as we explained earlier. The females, when they emerge, immediately begin foraging for pollen and nectar as fast as they can work, because the faster they work, the more babies they make, which makes them more successful bees, human bees. That doesn't work. They build their little nests and they fill all of those little cells. But by summer, 6 to 9 weeks later, that adult is dead. So of the year-long life cycle that it has, the adult portion that we see is actually the shortest portion of its life after the egg. They spend most of their life in the caterpillar sort of grub stage of their life. And just a short window of time is what's so important to us because of their use as pollinators. So the adults die, the larvae begin developing into the nest. They overwinter in that little nest, and the following year, when the temperature and the soil moisture and all of those things are right, they'll emerge and start the cycle over again. Many of these bees are specialists, which means that even when there's all sorts of flower resources that may be available for gathering pollen, they limit themselves to some subset of materials. And this isn't pollen for them, it's what they feed to their offspring. So I'm thinking about this kind of in the way that when I had my first kid, my first daughter, I was so careful about what I bought for her. And we were very organic all of a sudden and trying really hard to buy all of the best foods for my little girl. And by the time the second came along, I went back to eating in the normal way. But nonetheless, I was a specialist when I started in terms of what it was that I was feeding to my offspring. And that's what bees do too. So here, just for fun, is a little video showing you a moment in the life of a bee. So this is a squash bee. You can see she's a female, she's in there. She's been getting nectar, and I know that because her tongue's kind of out, but she's got pollen all over her body. So she's grooming it off of her antenna and her eyeballs. She actually has antennal cleaners built into her legs that scrape all of the pollen off of there. She brushes her eyeballs, moves all of the pollen from her forelegs onto her mid legs, and then from her mid legs onto her hind legs, which is where the pollen collecting hairs are, so she can carry it back. And then this is a male. She is clearly already mated, so she's not interested. They don't mate more than once, except in a couple instances. So he's going to go off and try another female. She's going to go to another flower and find more pollen and continue the cycle over again. So are these bees important on a scale of 1 to 5 now that we know a little bit more about them? Well, we haven't talked about what they do for our plants. In terms of agriculture, they're essential. We use bees so much, especially honeybees and a lot of our mason bees, in order to pollinate most of the flowering crops that we have. And this is really common across North America, depending on the crop that's there. But in addition to that, bees are responsible for the diversity in color and shape and scent and size and floral form for all of the different plants that we see in any natural landscape. All of these colors and scents and shapes are there as a result of the co-radiation and co-evolution of bees with their flowers. The bees communicate to the flower that they have something to provide, and the bee visits and then goes to another, and then the flower has to manipulate which bees come, and all of that results in this incredible diversity that we see. One of the really cool things about this is that the floral colors that we see are a little bit different than the ones that bees see. So well, we see kind of red through purple. Most bees don't see well in the deep red color. They see into the orange, so they see a little bit, but they do see well into the ultraviolet. Now, here's a fun little fact for you. This is true around the world, but in temperate regions with the big overstory like you guys have out there, there are some bee species that have evolved to have receptors that see better into the red, because that's the sunlight that's making it through the trees to the forest floor. So they actually have a special adaptation to being in areas where the canopy tends to be a little denser than in other parts of the world. So that's really, really cool. So if we wanted to look at a flower, this is one how we might see it. When you consider that ultraviolet reflection that's coming off of it, that's there just for the bees, just for the pollinators, it looks a little more like this. So there's this bullseye sort of pattern here in the center. Here's another just for fun. I just love the way they look. I wish I could see the world through the eyes of a bee just for a tiny period of time. And the result is this incredible landscape that we get to see. So are bees important? Yes, because they make our food tasty. All of our tastiest fruits and vegetables come from the bees. They help us with that, but also our natural landscapes, which I couldn't live without. So if you want to see bees in your yard, I would say the first thing to know is that they are already there. The first step is learning how to recognize the bees that are in your yard, because there's so many of them. And I guarantee you they're there. You just have to slow down, take your coffee out with you in the morning, and stand and stare at any flower in your yard for a while. And if, as long as it's not a red tubular flower that has hummingbirds on it, you're probably going to find some bees. Many of them are super small, and you'll watch them change as the season goes along, which is kind of fun. It helps, it pays to learn a little bit about the bees. So watching some of these insect videos that you guys have been putting up, anytime you can learn a little bit about the insects and the bees in the area around you, you're more likely to be able to recognize them when you're out. If you want to provide habitat, think of it as a bed and breakfast, right? An Airbnb. There's really just two things that a bee needs. And the first one is a place to live. As you know, most of them nest in the ground. So some undisturbed earth somewhere, some nest in sand, and some like nesting in lawns. So a diversity of different undisturbed earth is great. Limit the weed barrier. Bees have a hard time getting through it, either coming up or going down. Either way, it's a problem. And then provide cavities. This could be a rotting log somewhere. This could be a bee house that you bought. It could be bamboo, twigs. It could be last year's flower stems that you decided not to trim off. All of those provide homes for different kinds of bees. And then, of course, provide food. You can start small. If you're going to do just a little bit in your yard, I would recommend something in the sunflower family, because they have these big open flowers, which means you can see what's happening, which makes it fun for you. But also it attracts a lot of both generalist and specialist bees. And sunflowers tend to have a really long bloom window, so they can provide resources over a long period of time. Things in the mint family also tend to do really well. Things in the rose family, but not cultivars. Try and minimize the cultivars, just because they usually are big and showy at the expense of quality resources for the bees. I like to provide things that bloom from the spring all the way through the fall to account for all of the different seasons of bees. Big flowers and small flowers, and doing sort of contrasting colors can really help. But if you don't want to go all out, just something in a pot somewhere in your land is a really good start. This is my mom's yard. She lives in downtown Salt Lake City, which has like 1 million people. It's this huge city. And I don't know if you can see, but all of the lawns around her are just Kentucky bluegrass. That's all it is. It's just grass and trees that don't flower and attract bees. And in her yard, within a year of planting this, she had specialist bees that only visit cactus that somehow in the middle of downtown Salt Lake found her yard. And this sort of thing provides hope to me that just the littlest bit of help. They are opportunists looking for any opportunity to flourish wherever they are. So I'll quit there. In case you guys have any questions, I'll stop sharing. I'll check the chat here to see if there's anything. Leaf cutters are the best. I would agree with that. Tammy says she likes those. Are these deep nests used year after year? Margaret, yes, that's a great question. And we think they are. We don't know for sure on these, but we think it's successive generations of bees will reuse the same nest entrance, but continue to dig down. And the follow-up question to that that's really interesting is, why aren't they starting new nests in the same vicinity? And all we can figure is that the nesting resources that bees need are maybe more, they're more limited than we think. Like all ground may look the same to us, but to a bee, it could be that this area and this area actually are quite different from a bee's point of view, which is kind of an interesting thing to think about. Let's see. Is bee burrowing depth dependent on temperature or a combination of environmental factors? We think first and foremost that bee burrowing depth probably has more to do with the kind of soil that they have to go through, and also the size of the bee. So some of our teeny tiny perdita, the one I showed you that was smaller than a quarter, their nests are only about 6 inches, maybe 3 inches under the ground. They're really, really shallow, but it's also such a tiny bee that relative to its size, that's a pretty deep hole. Some of our bigger bees appear to go a little bit deeper than that. What was I going to say with that? So first and foremost, it's the material that they're nesting in. But the other half of that is that the offspring in the following year have to have some sort of environmental cue that tells them when it's time to come out of their nest. So they have to be able to sense the surface in some way. And it's only been studied for a couple bees because studying ground nesting bees is notoriously difficult. And what they found is that large rain events that bring the soil moisture and humidity in a little bee chamber up tend to cause the bee to finish out its development and then emerge from the ground. And that also the temperature at that level. So you can't go so deep that you don't recognize that. And it's a giant mystery. There's a lot there we're still trying to figure out. When I see the leaf cutters back out, turn around and back in, is she ready to lay an egg? With the leaf cutters, probably. She's either laying an egg or she's using her back legs to kind of seal off the end of that nest. And I'm not sure which it is when you're watching it. They do back in to lay the egg. Sometimes they can flip over in the nest cell and not have to back out to do it. But they also turn around to fold over the final bit of the little leaf envelope and seal that off. So I'm not sure which of those two, but it is possible she's ready to lay an egg. Do you know of any research comparing nectar and pollen quality of a native plant versus a nativar, which is a cultivar of the native? Not between a nativar and a native. This has definitely been done for cultivars, and there are definite differences. One in the amount of nectar that's produced, but also in the amount of protein in the pollen that's produced. But I don't know of any studies so far that have looked at that with the nativars. And that's something people talk about a lot is, are they okay? Because they're sure pretty. It would be nice to have some of those. And then Margaret also asks, Margaret, you have a lot of questions. This is great. If you have clay soil, can you expect many ground dwelling bees? You can expect certain kinds of them. So there are, just as there's, which ones, she says, just as there are certain bees that like to nest in lawns and certain bees that are adapted to sand. One of my favorites finds sand dunes and actually lands on it and then vibrates its body and will just disappear under the surface. And then under the soft soil where it gets a little harder, there's actually a tunnel. And somehow they know where to vibrate to get down to that. The ones that I know that are really common with the clay soil are the Haberpoda. They're kind of digger bee, and they seem to really like that clay soil, especially if it's in an angle. So like a clay bank, river banks and stuff like that, that are really clayey. I don't know if I have that picture somewhere. They'll actually build little tiny tunnels out of it, which are really cool to see. They'll actually modify the entrance and make these little tunnels. There are some Coletes, some cellophane bees that will also nest in clay. What else do I know of? The halictids, the sweat bees, I think nest in just about anything. So you might find them there as well. Are honeybees so different? They're not native. They are different in a lot of ways. And I think the big three are, one, honeybees make honey. No other bee in North America makes honey. Honey is, so a honeybee colony is something we call perennial, meaning that the same colony continues year after year after year, with the queen that's running or being run in that colony lasting up to 7 years. So she has a really long life cycle for a bee. That's a long time for a bee to live. And so because of that, and because they overwinter as adults rather than as little larvae that are munching on pollen somewhere, they need something to eat in the winter. And so honey is the equivalent of the way that I have applesauce and some pickles and some other stuff going downstairs from my garden. These guys have preserves. It's floral preserves. It's little jarred preserves to get them through the winter. So that's the first big difference, is that honeybees make honey and the other ones don't. Another big difference is that the honeybee colony can consist of maybe up to 30,000 individuals all living and working together and dividing up all of the tasks that have to be done when you have that many individuals, with one queen being the only thing that lays eggs. So one reproductive female, and all of the rest are just working to support her and all of their sisters. In all of these other native solitary bee situations, each individual female acts as the queen and the worker. So she builds and maintains the nest. She goes and gets the pollen and nectar, and she also lays the eggs. So she does everything that's necessary to keep her line going, which is different than the honeybee. Honeybees aren't native, whereas our native solitary bees, of course, are. There are maybe 50 or 80 introduced species here, but the honeybee is kind of the biggest one. And then the other thing is that because the honeybees live in these hives and these colonies, we can actually take them and move them around the country and put them in, you know, an almond orchard and then a cherry place and then somewhere else. And you can't really do that with our native bees that are nesting in the ground and stuff. So to my way of thinking, that makes them pretty different from all of these other bees. Yeah. How does climate change affect bee populations? Great question, Ren. And we're still trying to figure this out. And it's probably going to be this rather nuanced answer that will differ depending on which bee we're talking about and which environment. So for example, some of the pretty much the only research that's completed to date that talks about this talks about high elevation Rocky Mountain habitats where the climate change is so dramatic because they have such a short window of flowering. And they've found that the flowers have started blooming earlier. And the question is whether the bees that rely on those flowers will stay in sync with them, or whether there will end up being this asynchrony between the flowers and the bees that rely on them and vice versa. And so while we're seeing the asynchrony in the flowers, to date, we haven't seen the bees become asynchronous enough that they can't still benefit from each other. There's also thoughts that bumblebee declines, which are some of the only declines that we've quantitatively been able to document in bees. Bumblebee declines in some species may be a result of climate change because it's changed rainfall, precipitation, and temperature patterns. And so that might affect bumblebees, which are a holdover and a bee that was adapted to a climate that was here 15,000 years ago when it was a little more glaciary. So would they have gone away? Would they be in decline anyway? Maybe, but would they be declining this quickly? Maybe not. So a lot of research is still being done there, and we're not totally sure. Why are sweat bees named sweat bees? For the exact reason that you might think there, Dick. So what happens with these guys is that they land on your skin and will literally lap at the sweat on your skin. And so the reason that they end up stinging you is they're so small, you don't even recognize that they're on you. And then when you move your arm or bend your elbow or your wrist or something, you squish them and they sting you. And then you find that they were there. If you think lapping sweat is weird, you should hear about the bee in Thailand that actually drinks tears from people's eyes. They visit cattle and humans, and they'll actually, and they're tiny, 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 and they'll actually land on your eyelids and drink your tears. What are some of the predators of bees? So of the macro of the big organisms that we see easily, the biggest predators are some birds. You can think of woodpeckers and the damage they do to your house when they're going for the larva of the woodcutter bee, or the what they call carpenter bees, right? So that's one that you know is a predator of the bees, those woodpeckers. Other bees will, or birds will do the same thing in the ground and go down and get the ground nesting bees out of the earth there. Lizards out where I am can be predators as well. Spiders are huge predators. I don't know if you've ever seen them landing on flowers with their arms kind of out like this, waiting and then grab the bee. Robber flies are predators of bees. What else in the, oh, and other wasps. Wasps will predate bees as well. But most of the predators and things that lower the survival rate of bees are microscopic. So pathogens, molds, fungi, bacteria, those viruses, they even have viruses and those sorts of things. And one of the reasons that you guys have so many bees that nest above ground is likely a result of the fact that the soil where you are tends to be wetter than the soil where I am. So bees are more successful in drier soils because there's less fungus in the soils here, whereas your bees have adapted to not being down there where it's so wet. Mark says, I have a small yard in the middle of a subdivision. I see all kinds of bees. How far away am I attracting bees from? Oh, and how far do they rove? Great question. It depends on the bee. So the larger the bee, and they've actually studied this, so the distance between the wings on the back is correlated pretty nicely with how far a bee can fly. The exception, again, to that rule is the honeybee, which flies way farther than it should considering its size. But generally speaking, bumblebees will go out from their house about a mile. That's kind of where they cap it. Maybe if floral resources are really scarce or there's something really lovely that's a little too far away, they'll go for longer, and you'll find those bees maybe up to 6 miles from their home, but that doesn't happen as often. On the other hand, some of those tiny little bees, sweat bees, some of the smaller osmians and things like that, may not move farther than a football field or two in their whole life. Their entire existence is there. So I would say in your small yard, in your subdivision, if you're trying to attract bees, one thing to keep in mind is that the home that you put up for them should be connected by flowers to your large flower patch if you're providing. If you put too much space between those things, the bees won't be able to find both. So generally speaking, it's not a very long distance. In your intro, you showed a photo of yourself covered in snow. Yeah. Okay, that was April 16th. It should have been a great bee collecting day. And the day before, I got more bees on dandelions than I've ever gotten, ever. And then strangely enough, I was sweeping the ground, and I was with three other people. And I heard thunder, and I looked up, and here came this wall of precipitation. And then it got closer, and we realized it was this sudden blizzard, and we had to go hide from the lightning, and it snowed in an hour, like 6 inches on us, and we were totally unprepared. Our car ended up getting stuck, and we were stranded overnight, and the 4 of us had to sleep in the back of a really old Suburban, and we split an orange and a packet of chicken noodle ramen between the 4 of us that we watered down with, turned it into soup. We had a chicken noodle soup for dinner. That's only happened once though, once. Normally it's good bee weather. I think that's all the questions. Did I miss something? Well, you know how to reach me too. If you think of another, please, at any point, feel free to reach out and ask me more.
I think that was all the questions I saw. Did I miss any? This is a good time to ask.
That's right.
Yeah, something just came into chat. Let's see there.
A
lot of thank yous. This was a wonderful presentation. I agree. And yes. Cool. Olivia, I know everyone here, myself included, learned so much, and your enthusiasm is absolutely infectious.
Thank you.
And we really appreciate you taking the time. She had a busy school day and has been out in the field and still managed to squeeze this in. So I'm very, very grateful. And I'm also grateful for you all who showed up with your questions and your desire to keep learning. That's a wonderful thing. So I guess this is time to sign off, everyone. Is that good?
Good luck with
and by the way, please
have
join.
A good week.
Please, thank you so much. And by the way, please join Margaret Carrero. Would you like to say a couple of things about your program on Wednesday? No, she doesn't want to, huh? You're muted, Margaret.
Trying that, man, takes like 10 fingers to do that.
There we go.
Yeah, hi everyone. Yeah, I'll be speaking Wednesday night, and it's basically how we all can sustain our pollinators in our cities. Most people think you can't do conservation in the city, but you can. And we're not going to save the lions and tigers and bears, but we can save more birds and more pollinators, including bees. So
thank you, Margaret. And tomorrow night, there's a panel of 4 artists who will be sharing how insects inspire their art. And please check out all the other cool activities of Bugapalooza this week, including these amazingly fun videos, short videos that were done primarily by volunteer naturalists. Interviews with an insect at WBUG TV on YouTube. So
And
Thank you
I
all.
heard that you have a YouTube Bugapalooza playlist now, so you can
Yeah,
find
I just heard that. Yes, I'm excited. I want to thank you for reminding us of that. Thank you
I'm
so
gonna go
much.
check it out.
Me too. I'm sure it'll be good. We'll have some music with our live event on Saturday as well. Hopefully we'll have just the right amount of people and not too many, but we'll wear our mask and ask our visitors to if they're getting close to us and our bugs. But anyway, thank you so very much, Olivia, and thank everyone who joined us. You all have a lovely evening and hope to see you this week.